Welcome to algorithm video series. In the previous tutorial, we talked about upper bound problem. Today in this tutorial, let's discuss the logic behind the upper bound problem and its solution. Input for this problem is a sorted list with duplicates and a target element. Output is we want to find the first position where element is strictly greater than the target element. If our target is 30, we'll ignore all the elements which are smaller than or equal to the target element. We need upper bound here, that's why. If target is 30, ignore 10, ignore 20, ignore 30. Here 40 is greater than 30. This is the first position where this element is strictly greater than the target element. So this is our upper bound. In the previous tutorial, to solve this problem, we used modified binary search algorithm. What we need to do is, we need to take two pointers, low and high. Low will point to the first element, that is low equal to 0. High will point to the next element of the last element. That is, here high is length of list. Why? That is because here we want position, not the element. When we have an element greater than all the elements here, for example, target is 50, where I can place that element in this list at the 7th position, right? I'll get output as 7th position. That's why we need to take high equal to length of list. And we need to find the middle element like we do in the normal binary search. We need to compare the middle element with the target element. If middle element is less than or equal to target, then we need to ignore those numbers. So if middle element is less than or equal to target element, that means all the elements present in the left side are equal to or smaller than the target element. Because here numbers are sorted in the ascending order. If middle element is smaller than or equal to target element, then all the elements present in the left side is also smaller than or equal to the target element. So we need to ignore that. That's why in this situation we need to take low equal to mid plus 1. We need to search in the right side. Here this is our search area. Next scenario is when middle element is greater than target element. We want that position where middle element is strictly greater than the target element. But here problem is we are using binary search algorithm. In the binary search algorithm, we won't search in the sequential order, right? So we don't know that the position we got here is the very first position where the element is strictly greater than the target element. We want that first position. So for that, what I need to do is, I need to take this current index as one of the possible answer. Then we need to search in the left side, high equal to mid. I'll show you an example. Here this is middle, right? Let's take target as 10. Here middle element is 20. 20 is greater than 10. Okay, this condition is valid now. So what we need to do is, here we got a position where element is strictly greater than the target element. But I don't know whether this is the first position where the target element is greater than the middle element. So that's why I need to take this as my search area. I need to include this position also. So that's why we'll take high equal to mid. We'll take this as a search space. Here in this lower bound and upper bound tutorials, we used shrunk index method to solve problems. This method repeatedly halves the search space until one index remains. Here when only one element left in the search space, we need to stop. Okay, so this is about upper bound problem. That's it for now guys. Thank you for watching. Don't forget to subscribe to my channel. I will meet you in next class. Till then, take care.